So we'll take the next question. Question number 4. A rectangular member of width 200 mm and thickness 100 mm is subjected to a load of 180 kN at an eccentricity of 100 mm on axis bisecting the thickness. Find the maximum and minimum stresses. So here in this question, the dimensions of rectangular member is given 200 mm and 100 mm. About the location of load, it is given as the value of load is 180 kN. It is present on axis bisecting the thickness. That means this white line, that is x-axis, the load is present on this. Now what is the location of the load from the centroid? So that is given here, eccentricity 100 mm. So this total is 200, so half of it will be 100. That means the load is present here, that is 180 kN. Now with this we can solve the problem. So the given P value B, D and E, we have to find sigma max and sigma minimum. So first we have found out the value of direct stress, that is P by A. It is coming as 9 Newton per mm square. So direct stress sigma 0 is 9 Newton per mm square. Now next we will find out the bending stress, that is sigma B is equal to m divided by z. M stands for PE. Now what to take here, Zx or Zy? It depends upon the load. Load is present on x-axis, so we'll take the opposite of this, that is Zy. P value is 180, E is 100 divided by Zyy. So formula for Zyy is Zy is equal to dB square by 6. Substitute the values here, d b square by 6. So if we calculate this, we should get the answer as 27 Newton per mm square. So the value of bending stress is 27 Newton per mm square. So we have got direct stress and bending stress. Now it is easy to calculate sigma max. Sigma max is sigma naught plus sigma b, that is 9 plus 27, 36 Newton per mm square. Similarly, sigma minimum is equal to sigma naught minus sigma b, that is 9 minus 27. This is minus 18 Newton per mm square. So you can see here there is a minus sign which is coming. So if you want to write it whether in compression and tension, so the first answer will be 36 Newton per mm square and in bracket compression, because the value is coming positive, whereas the second answer will come as 18 Newton per mm square in tension. So either you can use the minus sign or you can use the compression or tension, whatever is present. Now here one more thing we'll do in this question, we'll draw the stress distribution diagram. So in the previous questions we have not drawn it, but in this question we'll try to draw. So it is very easy to draw. First draw the zero line. So this is the zero line. Now here first we'll mark the sigma max value. So on right hand side the sigma max value is 36. So this is 36. So this is the first point. And on the left hand side the value is coming as minus 18. So minus 18 means we have to go above. So this is 18. Now connect this. All the values below the line represent the compression, and above the line it represents the tension. So this is nothing but the stress distribution diagram. So if in question it is asked to draw the stress distribution diagram, you have to draw it like this. Remember the compression we are taking positive, that means all the values below this zero line, this represents the positive values, and all the values above the zero line it represents the negative values. this value is sigma max and this is sigma minimum.